Hi everyone, welcome to the episode number 20. Now, first of all, I want to generalize something. So, whenever you see to find all the possible solutions, all the possible combinations, all the possible subsets, all the possible paths in all of these questions, you must think in terms of recursion. Okay? And recursion and backtracking are not different, as I have been explaining in the previous episodes. Backtracking is just undoing the changes which we are doing. Okay? So, we do few changes so that we get the right answer. Then we call recursion to get the answer, and when recursion is done, then we undo those changes. As simple as that. Okay, so that step of undoing changes is called backtracking. That's it. Now in this question we are given a maze and a rat. A rat is basically lost in a maze. All right, so let me tell you what a maze is. So a maze is given as a grid, a square grid, where we have ones. These ones are the places where the rat can actually go. Then there are going to be zeros. These zeros are the places where the rat cannot go. Okay, all right, now we know what the maze is. Now the rat wants to reach to the index 3 comma 3. Okay, and if it is a n cross n matrix, then the rat wants to reach to n minus 1 n minus 1. Okay, the rat wants to reach to n minus 1 n minus 1. All right, now in the question it is given that the grid is square, but it doesn't matter. The algorithm that we are going to learn is going to work for n cross m as well, where the grid is rectangular. Okay, the algorithm is going to remain same. Now we have to basically print or to return all the paths that the rat can follow to reach from 0 comma 0 to n minus 1 n minus 1, basically to 3 3. Okay, now manually we can see that there are two paths over here. The first path is starting from here, then going down, then going down, then down, then right, then right, then right. This is one of the possible paths. Let us also write it down. So we are going down, 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 down. 3 times down, then right, then right, then right. 3 times right. This is one of the possible path. The other path could be down, so basically reaching over here. Then from here, let us take a right turn. So we will go here, then here, then here, then here, then here. So it's going to be down, right, 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 down, down. So down, right, 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 down, down. This is the second path. Okay, these are the two possible paths. We have to return all such paths. Let me also make some changes over here. So let us get rid of this and this, and let me add a 1 at this place. Now one possible path is this. Okay, one possible path is this. Now one other possible path could be, let's go this way, and over here, and here, and here. This could be another path. Okay, it is a longer path compared to the previous two that we have generated, but it is still a separate, a unique path. All right, let me write this one down as well. So it's going to be go down, then to right. So down, right, down, again down, sorry, again right, then up, then right, then down, then down, then down. Okay, so basically going down, then right, then right, then up, then right, then down, down, down. Correct. So this is another possible path. So similarly we have to generate all the possible paths. Now how is this problem recursive in nature? And all the possible paths that we are generating, we have to return them in a sorted form. So we will see how we can sort it very easily. So we don't have to worry about the sorting thing, that will be handled very easily. Just think that how we can generate any possible path. Okay, so for that again, this problem is very recursive in nature. How is it recursive? So basically we have to find a path from a particular position to the n minus 1 n minus 1, right, n minus 1 n minus 1. So we have to find the path from any random cell to this particular cell. All right, so the problem statement remains same. So let's say if we are starting from here, we have to find path from 0 0 to n minus 1 n minus 1, and let us say we are starting from here, then also the problem statement remains same. No, it remains exactly same. We have to find all the possible paths starting from 0 comma 1. Okay, so the starting index changes, but the problem statement remains same. It says that from wherever you are, find all the paths to reach this n minus 1 n minus 1. All right, so that's what we are going to do. That's why we can use recursion over here. Let's say if we are starting from this particular point, we will say okay, if we are starting from here, we will say okay, Where all can I go? I have 4 options to go. I have up, I have right, I have down, I have left. So these are the 4 possible options, but here we can see that we are left only with one option. Why? We cannot go up, we cannot cross the matrix, we cannot go left, we cannot cross the matrix, we cannot go right because it is a prohibited place. 0 is a prohibited place, as we have already discussed. This is the place where we cannot go. We can only go downwards. Okay, we'll go downwards. So we'll ask recursion to generate all the possible paths from this particular position. We will say, okay, my task is to visit all the possible places. Okay, my task is to go to all the possible places from where I am standing right now, and then from those new places I will ask recursion to handle rest of the task. Okay, so basically I can move in 4 directions, but here because of the prohibition I cannot go here, I cannot go here, I cannot go here, I can only go to this particular cell. But from here I will ask recursion to handle it. I will ask recursion to generate all the possible paths from this position to the final destination. Alright, now let us take an example. Let's say we are standing over here. We are standing over here, so from here also we can go in 4 possible directions. 2 out of these 4 directions are prohibited because of a 0, and from here we can ask recursion. From these 2 directions I can ask recursion to handle rest of the task. Alright, great. So that's what I'm going to do. Let's say I am standing at a cell I, j. Let's say I'm standing at I, j. From this cell I have 4 possibilities. One of the possibilities is to move upwards. So upwards means I minus 1 j. Okay. One possibility is to move downwards. It is I plus 1 j. One possibility is to move rightwards. So if I want to move right, it will be I, j plus 1, and if I want to move left, it will be I, j minus 1. So these are the 4 possibilities. So if I am standing at I, j, I will basically ask recursion to handle rest of the task from I minus 1, j, and then to handle rest of the task from I plus 1, j, and to handle rest of the task from I, j plus 1, and to handle rest of the task from I, j minus 1. Okay, so there will be 4 recursion calls in total. Alright, now one more thing, with these calls I will obviously generate the paths. Okay, I will obviously pass these paths. So if I am going to the, let's say, upward direction, if I am going to the upward direction, I will be passing up U. If I am going to the downwards direction, I will be passing D. If I am going to the rightwards direction, I will be passing R. If I am going to the leftward direction, I will be passing L. So these are the characters which I will be passing to recursion. I will say recursion, okay, I am going to go up, and from that position you do rest of the task. Then after this I will ask recursion, okay, now I am going right and I am passing an R. Okay, I am going right, I am passing an R. Now from this position, this right position, you do rest of the task. Similarly, when I will go down, I will pass D and I will ask recursion to do rest of the task from there. When I will go left, I will pass L, I will ask recursion to do rest of the task from there. Things will become much more clear once we start coding this. But before starting, there are a few things which I want to discuss. So let us say we are starting from this particular position, then we are going here, then we are going here. Now from this particular cell, I can obviously move to 4 possible directions. I have 4 possibilities: up, right, down and left. But the left position from where I am already coming, I cannot revisit it. I cannot visit it again. Okay, I cannot visit a position again and again. Otherwise, I will keep basically moving between 2 positions. So this is something which I cannot do. So I should keep track of what all places have I already visited. I should not visit them again. Okay, this is a very important thing. The other thing is to return the answer in a sorted form. So if I want to return the answer in a sorted form, I will try to generate the answers in a sorted form. And how can I generate the answers in a sorted form? So basically from a particular cell, I have 4 places to go: up, down, left and right. These are the 4 possible places. Now, which character out of these 4 characters is least lexicographically? I think D, right? D is least lexicographically. So first of all, I will go to the downward direction because I want to generate a path which is the smallest lexicographically. First, I want to generate the path which is lexicographically smallest. So D should appear in that instead of L and R and U. Okay, first D, then the next should be, next I should go to L. Okay, then R and then U. So this is the sequence that I should follow: down, left, right and up. Obviously I could have done them in any random manner as well. I could have gone left, right, up and down, But as I want to generate the paths in a sorted form, I should basically maintain this order. I should first try to ask recursion to generate all the possible paths by going downward. Then once the recursion has done that, then I will ask recursion to generate all the possible path going leftward and so on, so that I get the paths in a sorted form. Okay. Alright, so things will become very clear once we start coding this. Now let us talk about the space complexity and the time complexity. So here we can see that when we are generating the path, while generating the path, we are basically going deep inside recursion. We're basically going deep inside recursion. So let's talk about this particular path. We are going down, then right, then up, then what is this, right, then down, down, down. Okay, so this is the possible path, and the length of this path is equal to the height of the recursion tree. Okay, once we reach this D, the recursion is going to stop, but until then the recursion is going to go deep, right? So the length of this particular path is the height of the recursion tree. By height we mean that the space complexity. Okay, space complexity. Now in the worst case, what could be the longest path? So the worst case could be when we have all ones. So let's say here we have all ones instead of these zeros. So the length of the longest path could be the entire matrix. Okay, so let's say instead of 4 cross 4 we have a 3 cross 3 matrix. So if I want to find out the length would be this length of the path. If we are starting from here, going right, right, then down, then left, left, then down, then right, right. So the length will be the entire matrix. Okay, so if the matrix is n cross n, it will be like this. One path could be like this. Okay, so it's going to cover all the possible cells. And how many cells are there in an n cross n matrix? So n cross n number of cells. So this is going to be the height of the recursion tree, this is going to be the length of the longest word, and this is going to be the space complexity, n cross n. Alright, if you basically want to deep dive more into it, you can try to draw the recursion tree. Take this example, try to draw the recursion tree by yourself. Okay, it's going to be very simple because we have solved a lot of questions and we have drawn a lot of recursion trees as well in the past. Now at each particular step, how many options do we have? So at each step we have 4 possible options: up, down, left, right. You already know that. So if I draw the recursion tree, it's going to look something like this: 4 possible options. And in what sequence are we going to go? First down, then left, then right, then up. Okay, now from here also 4 possible options: down, left, right, up. Here also 4 possible options: down, left, right, up. Okay, so at this level we have only 1 node, at this level we have 4 nodes, at this level we are going to have 16 nodes, and the next level we are going to have 64 nodes. So this is going to be the recursion tree. It will keep expanding, and the height of the recursion tree is going to be equal to n cross n. This is going to be the height of the recursion tree. So basically that many levels are going to be there. So let us try to do a little bit of mathematics. So one node over here, then 4. We already know that the number of nodes is equal to the time complexity, right? So we are calculating nodes: 1 plus 4 plus 16 plus 64 till how many levels? Till how many levels? Till n cross n levels, right? N cross n levels. Okay, so this is a geometric progression. This is a geometric progression having n cross n number of terms. The common ratio here is 4. Let us apply that formula of finding the summation of the geometric progression. So it is a r raised to the power n minus 1 divided by r minus 1. This r is the common ratio. Common ratio is 4. Okay, what is a? A is the first term. First term is 1. So 1 multiplied by 4 raised to the power n. This n is the number of terms, minus 1 divided by 4 minus 1. So it is going to be 4 raised to the power n minus 1 divided by 3. This n is total number of terms, and total number of terms are n cross n. So 4 raised to the power n cross n minus 1 divided by 3. We can ignore this, we can ignore this. Why we can ignore this? Because this is very small. Like divided by 3 is very small, and minus 1 is also very small in terms of as compared to this. So the time complexity is going to be 4 raised to the power n cross n, as huge as this. Okay, because we have to generate all the possible paths, we will have to explore all the possible paths, and these many possible paths are going to be there in the worst case. Okay, So this is how you can explain the space complexities and the time complexities to the interviewer. So to the interviewer, you can first explain what is going to be the height, and the height represents the space complexity. So this is going to be the space consumed by recursion. Then you can say that we will also need some space to store the answers, the generated paths. So these many generated paths could be there, and this much space will be required to store them. This is how you can talk about space and time complexities, and it is going to impress your interviewers. And then you can say that this is going to be the recursion tree. At each particular node we will have 4 choices, so this is how the recursion tree is going to expand. And in this geometric progression, if we apply the formula of summation, we will get 4 raised to the power n cross n as the time complexity. Okay, so this is the space and time complexities required by recursion. All right, now let us try to code this. So this is the question you can read. We are given the exact question that we have just discussed. We have to return all the possible paths, and that is why we have to return a vector of string. Okay, now let us write the recursive function. Let us name that function as help int ij. This is the position. Ij is the position on which I am currently standing on. This n is given, so this is the position where I want to reach, n minus 1, n minus 1. Then the vector of vector matrix, this is going to be the maze. Then as we want to generate all the possible paths, let me keep a string path, and we want to store all these possible paths in a vector of string answer, right? So let me take a vector of string answer as well. Done. Now let us start solving this. So let us start with the base condition first. So if we are going to the wrong position, what is the wrong position? If we are basically crossing the board, so if I is going to go negative, or if j is going negative, or if I is equal to n, basically means that we are trying to cross from the downwards direction. Or if j is equal to n, it basically means that we are crossing from the rightward direction. Or if we are going to a prohibited place, that prohibited place is represented by 0. So if array of I comma j, it is ARR, right? ARR. If ARR of I comma j, if it is equal to 0, that means it is the wrong place to go. Don't go to that place. Okay, simply return from here. All right. Now, else if this is again a second base condition. The second base condition would be the good base condition. So this will be if I is equal to n minus 1, and if j is equal to n minus 1. Basically, we are standing where we want to go. We are standing at a correct position. So if we reach to the correct position, we should save this answer. So answer dot push back the path. Done. Save the answer, then return. All right. Else, now here we are standing at I comma j. We can move in 4 possible directions. All right, we can move in 4 possible directions, and we have already decided that how are we going to move. First of all, we will go down. After down, we will go left. Why are we following this order? To make the answer in a lexicographical order. Then to right. Then, so the camera is turned off, and don't worry about it. The camera just got heated up, so don't worry. We are almost done with the problem. So keep your focus here. This is the downward direction, leftward direction, upward direction, and right direction and the upward direction. So if I want to go down, what I will do is, first of all, the path, in the path, I will put a D, okay, push back a D, because I want to go to the downward direction. Put a D over here, and then ask recursion to do rest of the task. And because I am going down, I should do I plus 1. I plus 1, j will remain as it is, n, then ARR, then PATH, path, and then the answer. Okay, this is the downward direction. Now, as after the downward direction, I will go to the left direction. So I will have to undo the change which I am doing at the line number 10. So I am pushing a D, I should pop that. Pop, back, okay, done. Backtracking done. Alright. Now if you want to go to the leftward direction, first of all, let me just copy this and paste it over here. If I want to go to the left direction, I should push L for the left, and by left I mean j minus 1, right? And yeah, done. Then if I want to go to the rightward direction, what should I do? I should first of all push R, then rightward means j plus 1. Okay, done. Then if I want to go to the upward direction, I should push u. By upward it is I minus 1, and done. Okay, so these are the 4 possible directions I want to go in. Now one more thing which I discussed is, if I am visiting a place, I should mark it visited by something. Okay, I should mark it visited so that I cannot come to the same place again. I don't want to keep repeating the places. Let's say I'm coming from index 4, 3. Okay, if I'm coming from the index 4, 3, and if I'm going to the rightward direction, it will be 4, 4. Right? It will be 4, 4. Now, from the rightward direction, if I'm going to the leftward direction again, it will be 4, 3. Then again to the right, 4, 4. Then again to the left, 4, 3. I will just keep shuffling between 2 positions. I will get stuck there. So I don't want to go to the place where I have already been. Okay, where I have already been in the past. So if I'm going from 4, 3 to 4, 4, I should not come back again to 4, 3. So for that, what I should do is, I should mark that place as visited. So if I am visiting ARR of I, j, I should mark it visited simply by making it prohibited. Just make this place prohibited by putting a 0, and that's how you can mark it visited. Done? Okay, now you will never come back again to this place because you are making it 0. But one more thing is there. After doing all these 4 steps, after basically looking out in all the possible directions, just undo the change. Backtracking. Okay, remember, backtracking. Undo the change. I, j equal to 1. Okay, this is the backtracking step, and done. We are done with this. Now let us call this function from here. I will need to create an answer, vector of string answer, and a string path. Done. After this, I should call the function help from 0, 0 and n arr path answer, finally return the answer. And this is how we will be able to generate the answers in the lexicographical form, and it's giving us correct answer. Let me submit this, and it got accepted. So this is it for the problem. You can also try it by yourself. Link will be there in the description, and all the code in all the languages will also be there in the description. So you can definitely check it out and make sure that you try to submit this problem. Let us meet in the next episode with another challenging, interesting problem, and I hope now you will be able to solve all the questions by yourself. Thank you.